usually when we talk about cutting-edge technology, we tend to focus on the things right in front of us.
Right, yeah. The obvious stuff.
Exactly, like the smartphone in your pocket, the electric vehicle in your driveway, or, you know, maybe the smart thermostat on your wall. But today, we're going to look up, like way up.
I love this topic.
Yeah, it's fascinating. We're decoding the invisible infrastructure of our daily lives, specifically the commercial lighting systems that completely dictate how you experience the spaces you work, shop, and heal in.
Because the thing is, we only ever really notice commercial lighting when it fails us.
Oh, totally.
Right, like when a conference room feels like some sterile interrogation cell.
Or when a grocery store aisle just makes you look completely sickly.
Exactly. But when it's engineered correctly, it just vanishes into the architecture. It subtly dictates the entire psychology of the room.
And that is the mission for this deep dive. Today, we have our hands on a highly technical specification sheet for the FLUX ARC Indirect Linear Luminaire. That's by Auroion LED.
It's quite the document.
It really is a beast, lots of data tables. But our goal for you today is to basically strip away all that jargon and understand the underlying mechanisms here. We want to extract the primary technical advantages and summarize exactly why these features are solving massive, expensive problems for professionals.
Yeah, the architects, facility managers, the contractors.
Right, because on paper, you might look at this and just see, well, an aluminum extrusion with some LEDs inside.
A metal box that glows.
Exactly. But the engineering hidden in this spec sheet reveals a highly sophisticated, adaptive piece of tech. It's practically the Swiss Army knife of commercial illumination. So, okay, let's unpack this.
To really appreciate the engineering here, we first have to look at the traditional, the friction point in commercial lighting design. So imagine an architect is designing a massive facility, like a state-of-the-art research hospital, right?
Sure.
They're dealing with vastly different visual demands under one single roof. A patient recovery room needs this soft, ambient, warm glow to help them rest.
Right, nobody wants a spotlight in their face when they're recovering.
Exactly. But then 50 feet down the hall, a surgical prep area demands blindingly bright, crisp, highly directional light.
For precision work.
Precisely. And historically, that required specifying a completely different physical fixture for every single microenvironment.
Which means the poor facility managers are forced to stock, like, a dozen different types of replacement fixtures.
Oh, it's a nightmare for inventory.
And contractors are dealing with all these different installation methods. But the FLUX ARC spec sheet really leads with this concept of ultimate customization.
It does.
The standout feature they list here is an adjustable direct-indirect flux ratio.
Yeah, that's a big one.
But how does a single fixture actually physically alter the direction of its light? Like, are there physical shutters or baffles moving around inside the housing?
No, it's actually far more elegant than that. Mechanical shutters are, well, they're prone to breaking over time.
That makes sense.
Yeah, so what this luminaire has is an internal architecture with dual independent LED arrays.
Okay.
One array points downward toward the floor, that's your direct light. And the second array points upward toward the ceiling. That's the indirect light.
Oh, I see.
And what Auroion LED has done is use this really sophisticated multi-channel LED driver so the installer can just physically toggle a switch on the fixture, and that driver intelligently routes the electrical current.
Proportionally between those two arrays?
Exactly.
Wow, so it's almost like a graphic equalizer for a room's vibe.
That is a great way to put it.
So if I want to say punch light straight down onto a laboratory desk for high focus task work, I just set the driver to route 100% of the power to the downward facing array.
Yep.
But if I'm lighting a corporate lobby and I want to eliminate harsh shadows, I can flip that toggle, route half the power to the upward array, and bounce that light off the ceiling to create this massive, soft, ambient glow.
And what's fascinating here is they give you totally granular control.
Really? Like what?
You can set it to a 50-50 split or 70-30 split.
Yeah.
And why this matters for professionals is immense. Well, imagine an architect walks through a space during the final stages of construction, and they realize the room just feels too cavernous or maybe too intense.
Yeah, that happens all the time.
Right, and normally they'd have to rip the fixtures out of the ceiling and send them back to the manufacturer.
Expensive.
Incredibly. But here, the contractor literally just climbs up, flips a toggle on the driver, and instantly changes the volumetric feel of the room.
It's altering the physics of the room's illumination on the fly. That is wild.
It really is.
But it isn't just the direction of the light, right? It's the quality of the light itself. the specs highlight a 5 CCT field adjustable setting.
Yes.
Meaning the correlated color temperature can be toggled from like a warm 2700K all the way up to a crisp 5000K.
Correct.
But again, let's look at the mechanism. How is one fixture producing both a warm firelight yellow and a crisp icy blue?
So it relies on a tunable white LED circuit design.
Tunable white.
Yeah. Inside the luminaire, right on the printed circuit board, there are parallel strings of diodes.
Okay, I'm picturing it.
One string is coated in a specific phosphor blend, designed to emit a very warm 2700K light. And the adjacent string uses completely different phosphor blend.
For the cooler light.
Exactly, emitting a harsh, cool 5000K light.
Got it.
So when you adjust that CCT toggle, the internal driver changes the electrical resistance, essentially blends the current between those two strings to physically mix the photons.
Ah, so you can achieve 3000K, 3500K, 4000K.
Right.
So you are basically mixing paint, but with light waves.
In a sense, yeah. And from a physiological standpoint, this is so critical for modern commercial spaces.
Why is that?
Well, we know that cool blue spectrum light at 5000K suppresses melatonin production.
Right, it keeps you awake.
Exactly, it keeps people highly alert, which makes it ideal for, say, a fast-paced production facility or a really active office environment.
Sure.
But if that same space is repurposed for an evening networking event, that 5000K light is going to feel hostile, clinical.
Like a dentist's office.
Exactly. But by shifting the current to the 2700K diodes, the room instantly transforms into a relaxed, hospitable environment.
That flexibility is amazing. And it extends to the raw output, too. The spec sheet details a 4 wattage selectable feature.
Yes.
So depending on whether you're using the 2-foot model or that massive 8-foot model, the installer can select wattages ranging from 10 watts all the way up to 80 watts.
Which is a huge range.
The sheer output range here is staggering. We're talking 3,250 lumens at the lowest setting, up to 13,000 lumens at the top end.
It's basically a floodlight at that point.
But from an engineering perspective, building a power supply that can efficiently handle that wide of a load variance seems, well, incredibly difficult.
Oh, it is a massive engineering challenge.
How do they do it?
Well, a basic cheap LED driver is static, right?
Right.
It's designed to push one specific current to one specific load.
Right.
If you try to underdrive it, you lose efficiency, or worse, you introduce flicker.
Oh, I hate when LEDs flicker.
We all do. To allow a single fixture to scale from 10 watts to 80 watts requires a dynamic, constant current driver with a highly advanced microprocessor.
Wow.
It has to actively monitor and regulate the voltage drop across the LED arrays completely, regardless of which wattage setting the installer selected.
That's some serious hardware, but pushing 13,000 lumens is totally useless if the light makes everything look terrible.
Very true.
The document specifies accurate colors with a standard CRI of 80+ and an optional CRI of 90+.
Yes, color rendering index.
Right. I want to dive into the physics of that optional 90+ CRI, because we know it's notoriously difficult for manufacturers to hit that 90+ mark without sacrificing efficiency. Why is that?
It basically comes down to what we call the red gap in LED technology.
The red gap.
Yeah. Almost all white LEDs actually start their life as a blue diode.
Wait, really?
Yep. Manufacturers coat that blue diode in layers of yellow and green phosphor to convert some of those blue photons into white light. The problem is that standard phosphor mix struggles to produce deep, rich red wavelengths.
Which you need for accurate colors.
Exactly. So to push a luminaire to a 90+ CRI, which is absolutely mandatory in high-end retail where fabric colors must pop, or in healthcare where doctors are evaluating skin tones, you have to add specialized red phosphors to the mix.
And adding those red phosphors usually absorbs a ton of energy, right? Meaning the light gets significantly less efficient, it drops your overall lumen output.
That is the standard trade-off. Thicker, more complex phosphor coatings simply absorb more light.
Right.
But the fact that Auroion LED can offer a 90+ CRI option while still maintaining the massive lumen output and efficiency metrics we see in this spec sheet.
It's impressive.
It points to highly advanced phosphor chemistry and exceptional thermal management inside the fixture.
Okay, so we established that the FLUX ARC is basically a chameleon. It can mimic almost any lighting requirement an architect could possibly dream up.
Without a doubt.
But that brings us to a critical transition point. You can engineer the most beautiful, customizable light in the world, but if it is an absolute nightmare to physically mount into the ceiling...
The commercial contractors will refuse to bid on it.
Exactly. The physical integration has to be flawless. Now, the specs heavily promote a patented fast and seamless tool-free coupling.
Yes, they do.
I have to push back on this a little bit, though.
Okay, let's hear it.
Is tool-free really that big of a deal, or is it just a marketing buzzword? I mean, every single union electrician on a job site owns a power drill.
That's a fair point. If you're outfitting, say, a residential kitchen, turning a few screws is completely irrelevant.
Right.
But commercial construction is driven entirely by the mathematics of labor costs at scale.
Ah, scale. Okay.
Imagine outfitting a 100,000 square foot warehouse. You are not installing one fixture. You're installing endless, continuous rows of them.
Hundreds of them.
Exactly. Picture an electrician standing 25 feet in the air on a scissor lift. They are wrestling a bulky 8-foot metal extrusion with one hand, trying to balance it,
Sounds sketchy.
while digging into a tool bolt for a specific bit to mechanically join and wire it to the previous fixture.
Okay, I see the friction. Because if you drop a screw, you literally have to lower the entire scissor lift all the way down just to go get it.
Yes, every mechanical connection, every wire nut that has to be twisted adds maybe 5 to 10 minutes of labor per joint.
And at scale.
Multiply 10 minutes by 500 fixtures, and you're looking at dozens of hours of highly paid union labor just connecting metal boxes together.
Wow, okay. That adds up fast.
So a tool-free mechanism usually involves pre-wired internal harnesses and heavy-duty mechanical snap locks.
Meaning they just click together?
Pretty much. The electrician slides the fixture into the suspension cables, pushes it against the previous unit until it clicks, and the electrical and physical connection is instantly secured.
Bam, done.
The lift moves to the next position. It fundamentally alters the entire installation timeline.
So it's about removing friction at scale. That makes a lot of sense.
Yep.
And speaking of the physical installation, the mounting capabilities here cover everything. Suspended, surface-mounted, recessed drywall, T-grid kits.
They've got all the bases covered.
But what really jumped out at me were the LT and X connector models. These are geometric connectors. Why is this such a critical tool for lighting designers?
Well, it solves a major architectural problem: the broken visual line.
What's that?
Modern architecture really favors clean, continuous geometric lines of light. You know, lights that trace the shape of a hallway or form a massive cross over a central reception desk.
Oh yeah, you see that in a lot of tech offices.
Right. Traditionally, if you wanted two linear lights to meet at a 90-degree angle, you just butted the two flat ends against each other.
Which leaves a terrible dark spot right at the corner where the metal end caps meet.
Exactly. The dark spot destroys the whole illusion of a continuous light source.
So what do these connectors do differently?
The LT and X connectors in the FLUX ARC system are actually active illuminated joints.
Oh, they light up too.
Yes. The internal LED boards and the acrylic diffusers are engineered to overlap or perfectly meet at the apex of the curve or angle.
That's brilliant.
The light wraps seamlessly right around the corner, maintaining perfect diffusion.
Oh.
It allows architects to draw custom shapes on the ceiling without having to pay for custom manufactured one-off housings.
It's literally off-the-shelf customization.
Exactly.
And we have to talk about how these fixtures integrate with the building's nervous system, so to speak. The spec sheet notes an optional 2.5mm AUX jack specifically designed for a PIR, a passive infrared bi-level motion sensor.
Yes, and this directly addresses modern commercial energy codes, like California's Title 24.
Which are super strict, right?
Very. They mandate aggressive energy automation. You are literally no longer legally permitted to leave 13,000 lumen fixtures blasting at full power in an empty office corridor.
Makes sense. So instead of wiring a separate, complex sensor grid into the ceiling drywall and running low-voltage wire all the way back to a central relay panel,
Right, which is a huge pain.
the AUX jack just lets the contractor plug a motion sensor directly into the face of the luminaire itself.
That's true plug-and-play automation.
So when the corridor is empty, the fixture drops down to a dim ambient glow. And when the PIR sensor detects a human heat signature, it ramps back up.
Exactly.
And the dimming mechanism itself is crucial here. The specs state flicker-free 010V dimming capability down to 10%.
Yes.
Let's break down why 010V dimming is superior to standard dimming. Because look, we have all been in a room where a cheap LED tries to dim and it looks like a low-budget strobe light.
Oh, it's awful. The strobe effect is a byproduct of what's called phase cut dimming.
Phase cut.
Yeah, which is legacy tech designed for old incandescent bulbs.
Oh, okay.
Phase cut dimmers physically chop up the alternating current sine wave coming from the wall. They essentially turn the power off and on dozens of times a second.
But incandescents don't flicker like that.
Right, because an incandescent bulb has a glowing filament that physically holds heat. So it smooths out those electrical chops and just looks dimmer to the eye.
Ah.
But an LED is solid state. It reacts instantly.
Oh, so if you chop the power, the LED actually flashes off and on.
Exactly, which causes intense eye strain, headaches, and just a terrible visual environment.
Yikes. So how does 010V dimming solve the flashing?
It separates the power from the control.
Interesting. How so?
The luminaire receives a constant, uninterrupted flow of primary AC power. But there is a second, separate low-voltage control wire running to the driver.
Okay.
And that wire carries anywhere from 0 to 10 volts of direct current. So if the sensor sends a 10-volt signal, the driver pushes the LEDs to 100% brightness.
And if the sensor drops the signal,
say it drops to 1 volt, the driver smoothly and continuously scales back the constant current to the diodes, bringing them down to 10% brightness without ever chopping the main power line.
that is a brilliant piece of electrical engineering.
The result is perfectly fluid, flicker-free dimming.
Incredible. So we've established that the FLUX IRC can adapt to practically any aesthetic demand. And we know it installs rapidly with plug-and-play automation to save upfront capital.
Check and check.
But that brings us to the final frontier for any facility manager, the long-term operational reality.
Big picture.
What happens 5, 10, or 15 years down the line? This is where the engineering gets truly staggering to me. The spec sheet lists a lumen maintenance L70 of greater than 100,000 hours.
Yeah, in the commercial lighting industry, breaking the 100,000-hour threshold is the absolute benchmark for elite engineering.
Okay, here's where it gets really interesting. I had to do the math on this for you just to grasp the scale of that number. 100,000 hours.
It's a lot of hours.
If a hospital installs this fixture in a 247 trauma wing, and it literally never turns off running 24 hours a day, 365 days a year, 100,000 hours is over 11 and a half years of continuous operation. If you put it in a corporate office running standard 12-hour days, you are looking at over 2 decades. It's like buying a car that you never have to change the oil on for 20 years.
It really is.
But LEDs don't just suddenly burn out with a pop like an old tungsten filament, do they? What exactly does the L70 designation mean?
So an LED degrades over time due to thermal stress.
Heat.
Right. The heat slowly damages the semiconductor junction and degrades the phosphor coating we talked about earlier, causing the light to gradually lose its lumen output.
It fades.
Exactly. The L70 metric means that even after 100,000 hours of continuous runtime, the luminaire is certified to still produce at least 70% of its original brightness.
That's incredible. And to achieve that kind of longevity, the thermal management inside the fixture has to be absolutely ruthless.
It is the single most critical factor in LED lifespan, bar none.
How are they managing all that heat?
The outer aluminum housing of the FLUX RRC isn't just a decorative shell, it is a highly engineered heat sink.
Oh, the whole body is a heat sink.
Exactly. It's designed with specific surface area ratios to actively draw the heat away from the diodes and the internal driver capacitors, desiccating it into the ambient air.
Because if you trap that heat,
the LED dies in a year.
Oh.
By effectively managing the thermals, Auroion LED guarantees that decade-plus lifespan.
And while it's running for that decade, it is remarkably efficient. The specs note a luminous efficacy of up to 140 lumens per watt.
Which is excellent.
Right, which simply means for every single watt of electricity the facility manager pays for, the luminaire converts it into 140 lumens of visible light, rather than just wasting it as heat.
Exactly.
But commercial power grids are not always stable. The specs indicate a universal voltage input of 120 to 277 volts with an industrial 480 volt option.
Crucial for big facilities.
And critically, it highlights a robust 6 kV protection. Let's look at the mechanism there. What is 6 kV protection?
The 6 kV or 6 kilovolt protection is an integrated surge defense mechanism. Heavy commercial facilities like manufacturing plants or massive hospitals experience frequent voltage spikes when large HVAC compressors or industrial machinery power on and off.
Right, big power draws.
A sudden 6,000 volt surge traveling down the line would instantly incinerate the delicate microprocessors inside a standard LED driver.
Poof, gone. So how does the 6 kV protection stop the surge?
Think of it as a highly calibrated pressure release valve on a municipal water main.
I like that analogy.
The protection circuit utilizes components called metal oxide varistors, or MOVs.
MOVs, got it.
Under normal operating voltage, the MOVs do absolutely nothing. But the millisecond, a massive high-voltage surge hits the line. The MOVs instantly change their electrical resistance, acting as a shunt.
A shunt.
Yeah, they absorb that violent electrical pressure and safely redirect it to the ground wire, completely bypassing the delicate LED circuitry downstream.
So the surge never even reaches the light-emitting diodes.
Never. It takes the bullet for the fixture.
That is so cool. And the physical durability matches the electrical durability here, too. It operates in extreme temperatures ranging from -40 degrees Fahrenheit up to 122 degrees Fahrenheit.
That is a massive swing.
Right. Engineering a linear fixture to survive a 160-degree temperature swing requires incredibly precise physical tolerances.
Oh, absolutely.
The aluminum housing expands and contracts at a totally different physical rate than the acrylic diffusers.
If the engineering is sloppy, the fixture will literally warp and crack itself apart as the temperature shifts.
Exactly. Plus, it is UL listed for damp locations, meaning ambient humidity or, condensation in a parking garage won't short out the board.
And if we connect this to the bigger picture, when you synthesize all of these durability metrics together,
Thermal management, the MOVs.
right, achieving 100,000 hours,
Right.
handling 6 kV surges, the high efficacy saving daily electricity costs, and the structural integrity handling those extreme temperatures, you arrive at the ultimate metric for professionals.
Which is?
Total cost of ownership.
TCO.
Yes. Extreme ROI. The initial purchase price of a luminaire is practically irrelevant compared to the labor cost of replacing it.
That makes total sense based on what we talked about earlier.
If a cheap fixture fails after 3 years, the facility obviously pays for a replacement part. But more importantly, they pay a union electrician to bring a scissor lift back into the building, disrupt daily operations, and wire a new light.
The labor is the real killer. Auroion LED actually even backs this up with a 5-year labor warranty.
Which is rare.
Yeah, they aren't just shipping a replacement part if a driver fails, they are financially covering the labor to fix it. That proves they truly trust their thermal management and surge protection.
It is a massive statement of confidence in their own engineering.
So bringing it all together, our deep dive into this Auroion LED spec sheet reveals that the FLUX ARC is basically built on 3 distinct pillars of professional problem solving.
It's a great summary.
First, it solves the aesthetic challenges for architects through its dual-channel direct-indirect drivers, the tunable white circuits, and the high CRI phosphors. Second, it solves the logistical bottlenecks for contractors through that mechanical snap-lock, tool-free installation, the geometric cornering, and the plug-and-play 010V automation.
Frictionless at scale.
Exactly. And finally, it solves the economic reality for facility managers through its aggressive thermal heat sinking, the 6 kV surge shunts, and extreme luminous efficacy. It is not just a light, it is an adaptable piece of infrastructure.
It is the invisible backbone of the commercial environment.
Perfectly said.
And, I would leave you with this final thought to consider long after our deep dive concludes today.
Okay, let's hear it.
The next time you walk into a space that immediately makes you feel a certain way, whether it is the hushed, focused reverence of a high-end library, or the sterile, hyper-alert energy of a medical facility, or maybe the warm, welcoming embrace of a boutique hotel lobby lookup.
Look at the lights.
Consider the invisible psychology actively being projected onto you. That mood isn't an accident. It is being actively engineered by technology, quietly executing millions of perfectly calibrated electrical calculations above your head, completely unnoticed.
It fundamentally changes how you perceive the built environment around you.
Thank you for joining us on this deep dive. Keep looking up and keep questioning the hidden mechanisms of the world you walk through every day. We will catch you on the next one.